Okay. So in this section, we are continuing our work on looking at graphs and the behavior and what graphs look like. And so in this section, we're going to look at what happens when two or more graphs intersect. So again, we have this graph here, for instance. If we had, say, this quadratic and then we had this cubic there. We can analyze the points of intersection, which should be where they cross over. Okay, so it'd be there, there'd be one there, and there'd be another point of intersection there. Okay, and that's what we're going to look at. And we're going to look at potentially finding them as well. And remember, we already looked at this, and you would have seen it at GCSE, but essentially, when they cross each other, it's when the two graphs are equal. So the two equations are equal. So you solve them like simultaneous equations. Okay. And so there's not much new here in this section. However, I will advise we will be looking at sketching cubics, quartics, and reciprocals, I believe, which we'd all done in the last three videos in the last three parts. So this little chapter will subchapter or topic. You will need to know how to sketch cubics and reciprocals and stuff like that, which we did look at in detail a few videos ago, early on in this chapter, chapter 4, right, with graphs, because we will be plotting them. Okay, so let's just get stuck in then. So we have this example here, and it says on the same diagram, sketch these curves. Y is x of x minus 3, and also y is x squared 1, oh, 1 minus x. Okay, cool. So draw a big axis there. Okay, so first of all, again, we just need to sketch these two graphs. So hopefully you recognize the first one is a quadratic, right? Again, we know how to sketch quadratic. So firstly, what type is it going to be a positive quadratic or a negative one, if like that? Well, it's going to be a positive because we're going to the x squared coefficient is going to be, well, x times x is x squared. Well, it's positive 1, so it'll be a smiley U shape. And then, okay, so then we need the okay, so we know what shape we're looking for. So then we need the y-intercept, which would be when x is 0. Well, when x is 0, the whole thing is 0 because we're multiplying by 0 because it says x in the front. So it's going to pass through the origin, right? Cool. Then we just last need the roots. Well, the first root's at 0, and then the other one is this bracket equals to 0. So if x minus 3 is 0, x is 3. So it's going to be cool about there. Cool. So we have the information then to kind of have a sketch. Look like that. Cool. We might need to turn input, but we'll see if we need to be that detailed in a minute. Okay, now let's have a go at sketching this one. So hopefully you recognise this one is going to be a cubic because it's going to we get it the power is going to be x to the 3, x cubed. Okay, because we have an x squared here multiplied by an x will be x cubed. With that in mind, then what is the coefficient of x cubed? Well, it's going to be minus x cubed, isn't it? Which will mean it's going to be uh, that type of shape where it's going downwards. Okay. Okay. So then we need to then. Well, what's the y-intercept then? So it's going to be when x is 0. Again, it's going to pass through the origin because x squared will be 0. Then lastly, the roots. Well, we've got x is 0, but also the other bracket, 1 minus x is 0. So x has to be 1. Okay. So it'd be about there. Right. Cool. Um, Okay, and lastly, we did study what type of roots, remember? So this x squared, the origin, is going to be a double root because it's squared, which means, remember, it's going to sort of touch the axis like that, okay? And then for the other root, which is 1, it's just going to pass through it. So with that in mind, and it has to follow this sort of shape, it's going to look a bit like that. So it's going to come down here. It's going to touch it there, and then it's going to go down as so. Okay, it's a bit awkward to see. If I flash this out a bit more, hopefully you see that there's a point of intersection there. and then obviously it's going to cross at the origin because they both meet at the origin. Then they're going to meet again there. So there should be three intersection points, right? But that's sort of the graph, okay? Cool. Um, okay, but that's part A then. Part B, oh, we should label intersections, right? So that's three, that is one. So the intersection of the axis, and that's going to be zero, the origin. Okay, cool. Then part B says to find the coordinates of the point of intersection. So again, I just discussed. There's going to be a point of intersection there again when they cross over initially. Then they cross again at the origin, where we know what one route's going to be, one solution's going to be then. And then they meet again down here. So we're expecting three intersection points. Anyway, so that's part A. Part B then, well, to find the coordinates, we need to obviously find it exactly. Well, we can do that using algebra. So as I kind of discussed, we need to equate them together. So our two equations again is x of x minus 3 and y is x squared 1 minus x. So if I'm equating them together, because when the two graphs cross over, they are equal to each other, well, we can set the both y's equal to each other. So simply substitute we're going to get x squared 1 minus x is equal to x minus 3. So we're equating them together. Okay, well then, okay, we're going to solve. Let's just expand the brackets first, right? So we're going to have x cubed minus x squared. Oh, no, it's not x squared minus x cubed is x squared minus 3x. In general, if you see a bracket, it's best to expand it, right? Okay, well then let's rearrange a little bit. So I'm going to have minus x cubed. Then I'm going to move the x squared over here. Okay. Well, if I subtract x squared to both sides, I'm left with 0x squared, right? So then that's 0x squared, and then I'd move that minus 3x to the other side, so it's going to be plus 3x equals 0. Okay, well, I don't like the negative on the x cubed, so I'm just going to divide 3 by minus 1 to get x cubed minus 3x equals 0. So it looks a bit cleaner to me. Okay, so that's where we're at. Well, then I can solve this because I can factorize it, because then I can have x of x squared minus 3 equals 0. Okay, well then the solutions I get when I set each part equal to 0, right? These two uh, different parts of x. Either x is 0 or x squared minus 3 equals 0. But I can solve this by rearranging, right? To get x squared is 3. Well, if x squared equals 3, then x by square rooting is root 3. But remember, it's plus or minus because we want both cases when solving. So we want plus or minus. So every number possible that can, that when squared gets 3, right? Or root 3, I guess, in this case. Anyway, there we are. Yeah, so yeah. So any number that squares that squares it so times by itself to get 3. Well, minus root 3 times minus root 3 gives us plus 3, right? In the same way that positive root 3 and positive root 3 gives the same. Anyway, so that's what plus and minus then. Okay, well that's the x values, but it says to find the coordinates, remember, which means it needs to be in the form x, y, where we need the y value as well. Well, to find the y value, the corresponding y value, well, you just substitute it into either equation, right? Because y is equal to it. Okay, well then, let's take y is x of x minus 3. More simple one, right? Well, okay, well then we're going to plug in these x values then. So, firstly, if x is 0, y is going to be, well, 0, isn't it? Because we're multiplying by 0 effectively. So that would give the coordinate 0, 0. Then, when x is root 3, y is going to be, well, root 3 of root 3 minus 3. We can expand that, right? So root 3 times root 3, that's just squared, so it's just positive 3, right? Um, and then minus 3 lots of root 3. And yeah, there's nothing more we can do there. So then the coordinate that gives is when x is root 3, y is this 3 minus 3 root 3. Now you could give it as for giving it as a decimal, it doesn't say to round your answer to anything. And when you go further to A level and beyond in maths, it is a good idea to just leave it in what we call exact form. Okay, so is it any fractions or thirds? Don't try and convert it decimal unless it specifically asks you or you really need to. Just leave your answer in this. Okay, cool. Then we have x is minus root 3, okay, for the last value. Then y will be minus root 3 of might need to make room here. Minus root 3 of minus root 3 minus 3. Can we squeeze it in? Yes, just about. Okay, well then let's expand it. So minus root 3 times minus root 3 would be positive 3 again of positive 3, and then minus root 3 times minus 3 would be positive 3 root 3 again. Okay, so then that would give the coordinate when x is minus root 3, y is also, no, 3 plus 3 root 3. And there we are. So that's our three coordinates then. So coordinate is 0, 0, root 3, 3 minus root 3, and a minus root 3, and 3 plus 3 root 3. So those correspond to the points of intersection that I've labelled, right? So again, that would be minus root 3 for x, right? There. Obviously, that would be the origin, x is 0. That's the other point of intersection. And then the last one there is going to be when x is positive root 3. Okay, so that's corresponding to the points that we've worked out. Okay, cool. There we are. Let's have a look at this example then. Next example, on the same diagram again, sketch these curves. Y is x squared, 3x minus a, and y is b over x. Okay. So the first thing to note, there is some unknown letters here, a and b, but hopefully you recognise we're dealing with a cubic in the first one because we get x cubed, well 3x cubed actually, and here it's just a reciprocal 1 over x. But we just it's the same as long as you got that's the core graph we're working with. It doesn't matter too much about what letters there are, as long as we get the main gist of the graph. Anyway, with that in mind, then, well, firstly, let's sketch the first one, the cubic, right? So, firstly, what type of shape? Well, it's going to be positive because it's going to be 3x cubed. So, remember, it's going to have a sort of that shape instead, right? So, it's going to go upwards. Okay, then we need to find the y-intercept. So, that's when x is 0. Well, x is 0, we get 0 because there's an x in the front. Because we multiply something by 0, we get 0. So, it's going to go for the origin. Then we need to find the roots. Well, either x is 0, again, at the origin, or we get 3x minus a equals 0. Well, if 3x minus a is 0, well, then x would be a over 3. Okay, if we rearrange and solve. Well, again, that's not an exact number because we don't know what a is, but we don't necessarily need to know. Well, as long as it says A and B are positive. So all that means is it has to be on the positive x-axis, right? Because this will be a positive x value. Okay, it doesn't really matter where along the x-axis. We just need a sort of rough idea. So it's going to be, say, there. Okay, we can call that A over 3. Okay, it doesn't matter where, just pull it as like somewhere along the positive x-axis. Don't be too ridiculous. Don't pull it like over there, for instance. Kind of keep it sensible. Anyway, so it's positive x value because a is told to be positive, so this would be positive. So put that root on the positive x side. There, cool. Okay, so we've got the intercept. We know what shape it's going to be. It's a positive one. Now, we just lastly need to consider what roots we're dealing with again. So this x squared is a double root again, so that's going to be at the origin, so it's going to touch the origin. Remember, we looked at that when we sketched cubic graphs last time. The other root, which is x is a over 3, for this bracket equal to 0, that's going to be a single root, so it's just going to pass through a over 3. So with that all in mind then, graph is going to look a bit like this. So it's going to go up. Oh no, it won't. Sorry. It's going to pass through the origin there. No, it's going to touch the origin. So it's going to. There we go. It's going to touch it. It's going to go up, and then it's going to go up like that. Cool. There we are. I like that graph actually. And then we need to sketch this reciprocal. So b over x then. Well, we kind of looked at this last time. We looked at different multiples of 1 over x. So we had like, what's it, 4 over x and 10 over x. But they're the same graph, pretty much. So basically just sketch 1 over x, essentially, you know. B over x is just B lots of, so B times 1 over x, but it's just a multiple. It's the same sort of graph. Don't get bogged down by the unknown letter. We just essentially need to sketch 1 over x then, and we should know what that looks like. We looked at that last time. So when goes to 0, it goes from positive infinity. Then when x goes to infinity, as x gets large, it goes towards 0. We saw that last time. Then when x is negative to 0, it goes from negative infinity, and then it heads towards 0 again. So it's going to look exactly like that sort of graph then. So there we are. There we are. That's on the positive x side. Then for the negative x value, it's going to look a bit like that. Cool. Remember, there's also an asymptote at y0, which obviously y0 is the x-axis because it's tending towards 0. There we are. So that's how graph sketch again. We're going to expect two solutions there and there where they cross over. Well, that's part B, coincidentally. State given a reason the number of real solutions to this equation. Well, okay, that equation looks a tad bit like, how do we get there, right? What's this equation mean? Where's it come from? But let's break it down. X squared of 3x minus a is 0, minus b over x is 0. Okay, well then we can actually rearrange this b over. I noticed that this part is our cubic graph, and this b over x part is our reciprocal graph. But what if I put them equal to each other? So what if x squared 3x minus a by rearranging equals b over x? Well, then that just corresponds to the two graphs equaling each other. So y equals x squared of 3x minus a equals y is b over x. So the two graphs equal each other. Okay, so the solutions to this means it has to correspond to the intersections of these two graphs. As we just seen, we saw that are circled here and here. There were two intersection points. So the two graphs, y is x squared, 3x minus a, and y is b over x, uh, have two intersection points. Hence, there are two solutions to the equation, right? Okay. And in general, sometimes you might have to do that. You might have to do a little bit of rearranging to see clearly what graphs you're dealing with. Okay, to see what graphs you're equaling. Okay, like we did here, we have to move the b over x to the other side, which made it very clear what two graphs we consider. Okay, it's cool. There we are. So we have this example now. We are then asked to sketch the curve. Y is 4 over x squared, and y is x squared of x minus 3. Again, firstly, this is a reciprocal one. Well, 4 lots of over x squared. Well, that's just 1 over x squared pretty much times by 4. All we care about is the 1 over x squared. That's the main bit. We're multiplying like by summit doesn't change the graph, right? Doesn't change it. So just consider 1 over x squared again, like we did with b over x. So firstly, the graph 1 over x squared. Um, remember very quickly, we looked at that last time. If it's x squared, well, all that means is x is now positive because a square number is positive. So the right side of the reciprocal graph will match 1 over x actually. It will look exactly the same pretty much. Okay, but then for negative x values on this side on the left, well, it's going to match the right side because again, the negative is the same as positive because we're squaring. So it's going to match it. So on the left side, it's going to go from infinity again, and then as x gets larger, well, larger towards the negative infinity, if you get what I mean. It's going to go to 0 again. So it's going to have that sort of graph. Cool. There we are. And there we are. So that'll be our graph 4 over x. Okay. Oh, did I Uh, yeah, I did I should have actually. I should have labelled here the graphs clearly. So on the graph, I should have labelled that the reciprocal one was b over x, and the cubic one was y is x squared of 3x minus a. There we are. And I'm going to do the same here. So this reciprocal one will be y is 4 over x squared. Then we need to sketch again this graph, and then hopefully you recognise it's a cubic because we have, if we multiply all the x's, we get x squared times x will be x cubed. And with that in mind, if it's x cubed, it's positive, so it's going to have that sort of shape again. Okay, there we are. So it's going to go upwards. Okay. Well, then we need to consider what the y-intercept will be when x is 0. Well, when x is 0 again, it's going to go through 0, the origin there. Then we need to consider the other root. So that's going to be when x minus 3 is 0, the other bracket, the other factor. So that's when x is positive 3. So it's going to be like there, for instance. So label that as 3. Label that as 0. Cool. Well, then lastly, we need to consider the type of roots again. So this is x squared is a double root again because it's squared. It's repeating itself twice. X squared is x times x, so times by itself twice. Anyway, there we are. So it's going to touch it at 0 again, okay? And then for the other root, x is 3. It's a single bracket, so it's a single root, so it's just going to pass through 3. So with that in mind, then it's going to look like this. Again, if we go upwards, it's going to touch the graph there. It's going to go like that. And there we are, it's going to go upwards. So what we're going to expect in this case, if we equal the two graphs, is they're going to be one solution. Okay, but that's no graph. There we are. I'm going to label this one again. This graph is x squared, x minus 3. Cool, so that's our sketch done. Part B again, hence using your sketch, state with a reason the number of real solutions to this equation. Okay, that's a bit different, right, isn't it? There's no fraction, no reciprocal, and we've got an x to the 4 somehow. In that instance, well, it says using a sketch, so that it's kind of going to need to boil down to these two equations. But how do we get there? Well, we're going to need to kind of, well, we could try and rearrange the equation, but it's going to be quite awkward. I think instead, what we should do, because it says using our sketch, we're going to need to consider the intersections, right, of the two graphs. So let's equal our two graphs and see what happens. So y is 4 over x squared, and y is x squared x minus 3. Hopefully, if I then combine them and equal them when they intersect, I can kind of get this equation, right? Let's see. Well, if I equal them, again, when they intersect each other, 4 over x squared is going to equal x squared x minus 3. Well, let's expand the bracket first. So 4 over x squared is x cubed minus 3x squared. Okay, but then I can multiply everything by x squared because I have an x squared on the bottom here. So if I multiply both equations by x squared, basically cross multiplying, right? Think to GCC. To get rid of the fraction, I get 4 equals x squared of x cubed minus 3x squared. And then 4 equals x to the 5, if I expand it, minus 3x to the 4. Okay, then lastly, I get x to the 5. If I move the 4 to make it equal 0, x to the 5 minus 3x to the 4 minus 4 equals 0. Okay, let's compare the equation. We got our minus 4, but I noticed this is still factorized. There's no x to the 5. Let's see if I can factorize, right, this part here, this x is. Well, I can. I can see x to the 4 is common in both, so I can then say x to the 4 of x minus 3 minus 4 equals 0. Okay. How does that compare? Well, it's exactly the same now. I get x to the 4, x minus 3 minus 4 equals 0. So basically what we saw then is that this equation that they asked is identical to when these two graphs intersect, right? So when the two graphs equal each other, we can eventually get the same equation. That means then that there will be one real solution to the equation as it corresponds To what? Well, it corresponds to when the graphs equal each other. To when the graphs, and what graphs? Well, the graphs y is 4 over x squared, and y is x squared, x minus 3. Remember, those are the two graphs we sketched. Uh, intersect. And there is how many intersection points? And 1, right? So there we are, that's our justification. Cool, so hopefully you see how that worked then. So we equate the two graphs, noting graphically we circled there's only one intersection point, which was there. With that in mind, then we equal the graphs and then we get this equation. Okay, well, if we get the same equation by equaling the graphs, because there's one intersection point, there will always be one solution to the equation, no matter what equation we get from equaling. There we are. Cool. Okay, let's leave off this question then from the exercise. So this question, first it's again asking to sketch the graph y is x squared plus 1 and 2y is x minus 1. Okay, quite awkward graphs actually. So let's draw our axis then. Well, firstly, let's consider this graph, right, the quadratic. Um, well, firstly, what type of quadratic? It's going to be a positive one because we have positive x squared. Okay, cool. So it's going to be a positive U shape, a smiley shape. Okay, what next? The y-intercept. Well, the y-intercept is when x is 0. So that's going to be when, well, x is 0, you just get plus 1. So the y-intercept would be 1 there. What about the roots? Well, actually, I can kind of spot there are no roots. Why? Because the roots occur when y0, because it has to be on the x-axis, right? Which is when y0. But if I set y0, then x squared plus 1 equals 0. If I were to rearrange that, x squared would be minus 1. And then I'd have to square root it, wouldn't I? But I can't square it a negative. So there are no roots and no solutions. So if there are no solutions, remember, think back to the discriminant, that means it will not touch the, well, there are no real roots, and that means graphically, no roots means it can't touch the x-axis, so it will never cross the x-axis. Okay, so it's going to look a bit like that then. If it won't touch the x-axis and it has a smiley shape, it has to be above the x-axis. Okay, anyway, lastly then, but I don't have a lot of information really. I'm going to then sketch where the minimum point would be. So how do I find the minimum point? So remember, of a quadratic curve, the minimum point is the bottom point there, a turning point, right? We complete the square, right? So I'm going to do that over here. Y is x squared plus 1. Um, well, um, this is actually completed square form, actually, because think about it, this is like a bracket of x, all squared. But there's no, what's it, ax squared plus bx. Let's see. There's no bx term, there's no x term. So I'm only left with just x squared. So this is in completed square form already. So if I set the whole bracket to 0, well, that means x is 0, right? And then the corresponding value for the turning point would be with y is 1 if the whole bracket is 0. That means the turning point is actually when x is 0 and y is 1. But that actually is the y-intercept, funnily enough. So the y-intercept is the turning point in this case. Okay, cool. Okay, so then we can kind of sketch the quadratic. So it's going to look like that. Cool. So there we are. Then lastly, we need to sketch this line here. So if 2y is x minus 1, well, this is a line because if I halve it, I get y is a half x minus a half. Okay. If that makes it easier to see what you're doing. But how how I draw line graphs is again, I try to just find 2 points on the line, and then once I find the 2 points, I kind of just connect them. Okay, you could do gradients of y-intercept. Well, the y-intercept would clearly be minus a half. That might help. There we are. Um, okay, but then I need another point. Well, let's find where it is on the x-axis then. There, when the root of it, right? When it crosses the x-axis, which is when y is 0. So if y is 0, then a half x is equal to a half, right? If I rearrange this equation. But then x then, if I times by half, I get x is 1. Okay? Well, times by 2, sorry, to both sides. Half times 2 is just 2 over 2, which is 1. So actually, then it crosses the x-axis at 1. So therefore, I've got 2 points. Um, so then I'm going to use a ruler. I need to get my ruler out. There we are. So I'm going to connect the 2 points with a ruler and then draw a line through it. Okay, so I need to line up my ruler. To connect through the y-axis at minus a half and x at 1. There we are, that's good enough for me. So line the ruler up to go through the 2 points and then simply draw your line. Coolio. There we are. So then we need to label our lines, right? So that'd be 1 there. So that will be y2. Well, 2y is x minus 1, and this will be the curve y is x squared plus 1. So there we are. We sketched our graphs then. Okay, that's part A done. Part B then it's saying explain why there are no real solutions to the equation 2x squared minus x plus 3 is 0. Well, it's very similar to what we did just before with the last example. We need to kind of equate the two graphs and then we get an equation. Well, actually, notice this is a quadratic, actually. How can we easily work out or identify whether there is any solutions to a quadratic? The discriminant, right? So very easily you could just work out b squared minus 4ac. However, I'm going to do it using the graph because that's what we're looking at in this particular section. So let's think, well, it's not abundantly clear how I get this equation, but it's basically asking us to consider the graph, right? They didn't ask us to sketch the graph for no reason, right? So let's consider the graph. Let's consider when we put them equal to each other, right? So y is x squared plus 1, and 2y, sorry, is x minus 1. So I'm going to put them equal to each other. Obviously, they never intersect, so I'm expecting those solutions. That's okay. I can still equal them, equal the two equations together. So y is this, then I can substitute y into here, right? So if I call these equations 1 and equations 2, I can say sub y into the second one to get 2y, which is 2 lots of x squared plus 1, is x minus 1. Basically, not simultaneous equations, right? Then I could expand the bracket to get 2x squared plus 2 is x minus 1. They're going to move the right-hand side here to the left to get 2x squared minus x plus 3 equals 0. Okay, well, that's the equation I get. 2x squared minus x plus 3 equals 0. That's the equation they want you to consider. But there we are. So again, it's going to be the same sort of reasoning then. So, therefore, and I can use these 3 dots to represent therefore, the equation has no real roots since the graph y is x squared plus 1 and the graph 2y is what was it? 2y was x minus 1, was it? Yes. Or you could say y was a half x minus a half, doesn't matter. And 2y is x minus 1 do not intersect. Okay, cool. There we are. Alternatively, again, you could answer that question by um, what's it called? By using the discriminant. I could add a little bit more detail here. I could say not intersect. And the equation 2x squared minus x plus 3 stems from equating these two graphs, right? If you wanted to just be absolutely transparent and say, well, if you equate the two graphs, well, then you also therefore get this equation. So therefore that corresponds to how many intersections there are with the two graphs. Anyway, there we are. Then for the last question, part C, it says work out the range of values of A such that the graphs of y is x squared plus A now and 2y is x minus 1. So they're very similar, except A it's now not plus 1 here, it's just plus A for some number A. Have two intersection points. Okay. Well, again, let's consider y is x squared plus A and 2y is x minus 1. Well, if they equal again, so we want to it's talking about points of intersection, right? So if we're considering points of intersection, again, we need to equate the two graphs together to get those points of intersection. So if I equate them together, so I'm going to then say if y is this, well then I can substitute it into the other equation. So that means two lots of y, which would be x squared plus a now. It's going to be x minus 1, and that's an a to be clear. There we are. Then I can expand it to get 2x squared plus 2a. And I'm going to move the right hand side to the left to get minus x plus 1 equals 0. Going to ever so slightly tidy this up a little bit, rearrange to get 2x squared minus x plus 2a plus 1. So it looks exactly like a quadratic form, right? Okay, so that's the equation we get. Cool. It then says that the two graphs, right, have 2 points of intersection. Remember, we did work on this when we looked at quadratics and simultaneous equations. We have a quadratic here, right, and it's talking about basically if there's 2 points of intersection, there's two real roots. Well, has two real roots, but what does that mean then? That means the discriminant, right? It's all about the discriminant. And the discriminant has to be a positive, it has to be above 0, right, to get two real roots. Remember, we looked at this when we looked at the discriminant. So there we are. But then we can substitute these values in the coefficients a, b, and c into this equation. So therefore, well, b squared be minus x and minus 1 all squared minus 4 lots of a, which would be 2, and c, which would be this whole number here, 2a plus 1. So remember, a is a number, so this whole thing is just a number overall. So that'd be the c. That's all greater than 0. Then we could just expand to get positive 1 minus 8 of 2a plus 1. Minus 4 times 2 is minus 8. And that's all greater than 0. Then I could expand it even more to get 1 minus 8 times 2a is 16a. Minus 8 times 1 is minus 8, greater than 0. Then I have minus 16a. 1 minus 8 is minus 7. Well, I could just move the 7 to the other side, right, to get greater than 7. Cool. Okay, well then I'm going to divide by minus 16. So I'm going to get a. Well, if we divide it, well, notice here we divided by negative 16, but it's a negative. Remember, with inequalities, the caveat is divided by or times it by a negative. We have to flip the sign of the inequality. So it's now less than minus 7 over 16. Okay, because we're dividing 7 by minus 16. Remember, so there we are. There we are. So that's our range of values of a. That's the solution. That's the inequality we get. Because remember, it says there's no more stipulation. It doesn't say a is positive or negative. What? No, that's just it. Just literally says work out the range of values of a. That's what it did. That is a range of values for a. That inequality there. So there we are. Cool. Um. So that's intersection point. So again, nothing new there, but you have to get really comfortable and used to the idea that when two graphs intersect, you equate them together, and how does that translate to how many roots it has For example, it might ask you for how many real roots there are to a particular equation as we looked at. So you have to equate the two graphs together, or you might get a quadratic like we did, and you might have to use a discriminant or something using how many solutions we know. So in this case, we know there are two solutions, so we have to use a discriminant to be positive. Okay, cool. So I'm going to leave that there then, but I'll see you next time.